Hey guys, and welcome back. So in this week we covered a lot of stuff, and that includes fracturing techniques, a variety of fracturing techniques and constraint creation techniques, as well as the wood and how we can get the wood splinters and all that stuff. And I want you to incorporate whatever is valid for your scene from what we covered here. If you can add some wood structure, that would be great. I think implementing the wood fracturing is very important with the matrices and stuff. That's very important to master and understand. The cone twist, getting this to be at a stable position, adding simple stuff like the ground, the rooftop, and also we should be thinking about choreographing the destruction itself. So we added that impact positions at the impact points, and that technique can be used to create a lot of cool effects. You can also consider breaking the ground and adding some stuff to, like have some explosions on the ground if you want to, or have some timed impacts hitting a wall, or if you have a building you can destroy an entire floor or two floors and time all the explosions there. And I think there is a lot of potential, there is a lot of material, and I want you guys to explore all of this, all of these techniques and everything we covered: fracturing, constraints, and explosions, effects, and try to incorporate all of this into your scene with whatever geometry you have. If you don't have a lot of details, a lot of geometry, try to think of to add actual wood structure. If you don't have something that like this that has a lot of interconnection in itself. So if you don't have something like this, which is pretty simple, I mean, you can model this fairly quickly. If you don't have something like this, maybe you can find a place where you can have a cohesive structure that has a lot of interconnection in between that you can use to create some cool wood fracturing, which is by itself is very nice to look at. So I think that's pretty much it for this week. The goal is, again, to add more layers to the sim, more fracturing, definitely the wood and the matrices and all that stuff, and then to try and get something stable, a stable sim that doesn't take too long to sim. Obviously, I know Bullet can get really expensive with high-res geometry, but as long as we are staying safe with that, it should definitely be fine to work with. Now here, the geometry that I have is fairly mid-res. I don't have anything high-res, and the only piece that I'm not happy with is this guy. Where is it? Let me find it. The roof, the tiles. Yep. So this is the guy I'm not happy with, and the reason for that is because all this, it's a lot of geo for no reason. Okay, and after we did the, where is the, not the connect, looking for the, okay, so here we have, this is our high-res roof, and it's ready and all that stuff. What I want to do here is to create a low-res version that we can use with Bullet. So I can do for each loop quickly and do a remesh, or a poly reduce is much better for when we want to optimize stuff. And I want to keep not 20 but maybe 40%, 50%. Okay, this is going to generate the same convex hull geometry, and actually what Bullet is going to do is going to do exactly this. Tidrahilize node, going to change this to a convex hull. This is what Bullet is going to do to wrap this geometry. Okay, it's going to do this, and by poly reducing it, we're not going to change the convex hull, we're just going to reduce the mesh. So here we didn't change the name attribute or anything, but we made the geometry a lot lighter to work with. So we can use this inside the sim, and then use this high-res version to for the final render with the transform pieces node. And I think that's pretty much it. Good luck to you guys, and see you next week.